this video today, my Math 3 scholars, we're going to consider how to look at the transformations of exponential functions and their graphs. So this should look a little bit familiar to you, except it's in exponential form now. So we have f of x equals ab to the x minus h and then plus k. So hopefully you will remember that the h moves left or right, and the k, your h moves left or right, and the k moves up and down from your original function, okay? And I just want to make sure that we look at these. And I actually have written that here for you. H moves the graph left and right, and k moves the graph up and down. Now, again, the best way to do these is going to be by just looking at these graphs, and let's plot in some points and see what we come up with, okay? Now, there's some things we're going to list here. So let's see what we can do here. Does this represent a growth or a decay? Okay, when we look at that, we look at this 2 right here. If this 2 is greater than 1, that means it's a growth. So this one represents a growth. All right, the transformations, I have an h that is plus 2, that's x plus 2, so that means it's going to move it left 2, because that means my h is negative 2. And I also have a minus 1 on the end, which means it's going to move it down 1 unit. Okay, my horizontal asymptote here, we're going to figure that out as we go here, okay, because this one is moved. Since it's moved it, we can't always say that it's the x-axis, okay? So we're going to figure that out as we do our points over here. The domain of all exponential functions is negative infinity to positive infinity. And our range, we may have to wait to figure that out too, okay? So let's look at our range and see what that is here in a minute, okay? All right, so if we pick out some points that we're going to put in here, then let's, we know that we could try to start with 0, right? So I'm going to put 0 in the middle here and start with 0. Okay, if I put 0 plus 2 in, 0 plus 2 is 2. 2 squared is 4. 4 times 3 is 12, and 12 minus 1 is 11. So I know that I'm going to have the point 0, 11. Now these are different. Before we knew we had the point 0, whatever this was. But we can't say that with these because they've been shifted, okay? So we've got the point 0, 11. What if I put in, let's see here, what if I put in a negative 1? Let's try that. If I put in negative 1. Negative 1 plus 2 is 1. 2 to the first would be 2. 3 times 2 is 6, and 6 minus 1, that would give me 5. So at negative 1, I get 5. So it looks like this thing's coming down. Y'all see that? Looks like it's coming down. Let's try negative 2 and see what we get. If I put in negative 2 plus 2 is 0. Anything raised to the 0 power is 1. 1 times 3 is 3, and 3 minus 1 is 2. So I'm going to get negative 2, positive 2. All right, so it looks like we're coming down. Now we've just got to figure out what this is approaching. So let's hop over to negative 4. Let's put in a negative 4 and see what we get. Negative 4 plus 2 would be a negative 2. So that would take that down to 1/2. Half of 3 would be 1.5, and minus 1, that would give us a 0.5. So at negative 4, we're going to get 0.5. Okay, now we've got to see if we cross this axis here. Let's put in negative 5 and see what we get. Now if I put in negative 5, then negative 5 plus 2 is a negative 3. Let's see what 2 raised to the negative 3 power is. That's 0.125. Okay, times 3, and then minus 1. Okay, that gives me negative 0.625. Negative 0.625. Okay, so that's negative. So that means I'm going to come down here to negative 0.625 down here. So it looks like that what I'm going to be approaching is this line of y equals negative 1. Okay, So my asymptote here is going to be the line y equals -1, which means that my graph is going to come down and do this. It's going to continuously approach that line, but it's never going to touch it. So that means all my y values, my range, are going to be from -1 up to infinity. So this is going to be -1 to infinity. Okay, let's do another one over here. Let's look at -4 to the x plus 1 plus 3. Let's see what we get here. So is this a growth or a decay function? So notice that this one is going to be a decay function, okay? This is going to be a decay because it's a negative out front. So this is going to be a decay function. Our transformations here, we've got a +1. So if we've got a +1 here, then that means it's going to be moving it to the left 1. And it's going to be moving it +3, which is up 3 units. Okay, we don't know our horizontal asymptote yet. We do know our domain. It's -infinity to +infinity, and we don't know our range. All right, let's see here what we can do. Let's try filling in a 0 and see what we get. If I put 0 in, 0 plus 1 is 1. 4 to the first power would be 4, and then -4 plus 3 would be a -1. So that would be 0, -1. Get that point. All right. Let's try -1. I'll fill in -1. -1 plus 1 is 0. 4 to the 0 power is 1. So that would be -1 plus 3, which would be a 2. So at -1, I get 2. All right, let's try -2. If I got -2, -2 plus 1 is -1. So 4 to the -1 power is what we're doing. That would be 1/4, because you have to flip that. So -1/4 plus 3 would give us a 2.75. And you can do that on the calculator to get that. So this at -2, we're going to get 2.75. It's pretty close to that. Okay, what if we put in -3? We put in -3, and I'm going to show you guys how you can do this on your calculator if you want to, so you don't have to do it in your head. So I would do negative, and then I would do 4 raised to the, putting in -3 plus 1. You can get that, and then add 3 to it. So we get 2.9375 for that one. Okay, so we're just getting closer and closer to this asymptote of y equals 3. So this is our asymptote this time. And it's going to be y equals 3 is our asymptote. Okay, so that means that all of our graph is going to do this and come down like this and continue that way. And it's going to get closer and closer to that 3, but it's never going to touch it. So all of our values down to -infinity up to 3 is our range. So we're going to have -infinity up to 3. That's going to be our range. Okay, pause the video and try to do this one and see what you come up with. Okay. Okay, hopefully you've worked this one. And since this is negative here, we know we've got a decay function. Our transformations, we didn't move any to the left or right because there's no plus or minus here on the x, but we have a +1, so that means we moved it up 1. Okay, so let's start off by putting a 0. If I put in a 0, 3 to the 0 is 1. -1 plus 1, that'd be 0. So I've got the point 0, 0. All right, let's put in -1. And I'm just going to go to the calculator to do it. So I'm putting in, clear that out, -3. Let's put it this way. Negative, and then 3 raised to the -1 power, and then +1. Okay, you can see we get 0.6666. So that's basically 2/3. Okay, so we get 2/3 there. So -1, 2/3. Okay, what if I put in -2? Let's just see what we get. I can redo this and just change my thing to a -2 here. Okay, I get 0.88888. So if I put in -2, we can tell that that's just slowly approaching that. So we're just going to get closer and closer to this line, it appears. So it appears that this is going to be our asymptote here because we're getting closer and closer to that. But I want one more point down here. Let's put in a 1 and see what happens. 3 to the first is 3, and -3 plus 1, that would be a -2 if I put in 1. So at 1, I'm going to have -2. I just wanted another point to graph this with down through here. So we know that that's going to do that, and this is coming up, and it's going to approach this y = 1 line, which is going to be our horizontal asymptote, but it's never going to touch it, okay? Our domain here is going to be -infinity to +infinity, and our range, sorry about that, our range, since this continues down, is going to come up from -infinity, and it's going to approach that line 1. So we're going to have -infinity to 1. Okay, I just wanted to introduce these transformations to you and let you see what they look like when you move these things around on the coordinate plane. As always, if you have any questions, let me know.